Alright, hey guys, today we're going to be doing an experiment called hallway vectors. And before we begin, I just want to make sure that everyone knows that a vector is a measurement that includes direction, whether that be north, south, east, west, or even a specific degree. Alright, so now that we know that, we can begin the experiment. So what we had to do was we had to trundle from Ms. Clayton's room to Mr. Buford's room to find the displacement vector and the degree in which it was traveling in. So in order to find the displacement vector in this degree, we had to not only measure the numerical distances, but we also had to record the direction that we were traveling. So here is the route that we took, and over here is where the sun rises, so that would be the east by the gym, and that means that over here by the auditorium is going to be the west, and that means that down here by the guidance would be the south, and up here by Mr. Buford's room, where we're actually trying to go, would be the north. And so we start over here at Ms. Clayton's room, and we traveled first east for 26 meters, and then we went north for 55 meters, and then we went east again for an additional 31 meters. So because we actually have two measurements that are both going east, we can add them together using summation. Here's the Greek symbol here. It kind of looks like a backwards E, but it just means to add or like addition. So that way, instead of having 3 steps, we can add the 2 east steps together to just get 1. That way we have 2 steps instead of 3. So now we have the east direction, so 57 meters east, and we have the north direction, which is 55 meters north. So now we can start the math. So for part 1, I would advise to draw a diagram. So for this diagram, you want to take the 2 directions, pick a scale, and then I just started with the eastern component. It doesn't really matter, but as long as you follow these rules. So you can start the east. So I went to the east, and you want to make sure that you draw the arrow in the direction that you're going. And then for the northern component, which I added second, you want to start from the end of your first one. So I'm going to start at this arrow and go up for the northern. Make sure that you have your arrow up here. Alright, and then the hypotenuse would be right here, going in the direction of the arrow of the last one. So it's going to meet with the arrow of the northern component here. So in order to find this hypotenuse, or this displacement vector, you can use the Pythagorean theorem. I'm sure a lot of you have seen this before. A squared plus b squared equals c squared. So you just plug in these legs here, do the math. You find that the hypotenuse is 79.2 meters long. So that's only part 1 though, because we still have to find the degrees. But so now we know that the displacement vector is actually 79.2 meters long. Alright, so now we have to find the degrees. I would advise that you draw a coordinate plane as shown by the dotted black line, just because it helps to tell you which angle that you actually have to find. That way you don't end up finding, this one, which is the wrong one that you don't really want. So you draw the coordinate plane. You want the angle that's closest to the origin, so that would be this one here. And then you can use the inverse of sine to find this angle. So sine is opposite over hypotenuse, so we're going to use the inverse sine of 55 meters over 79.2 meters, which is what we just found in part 1. And then you're going to plug that in the calculator, and you're going to find that you get 43.93 degrees. And that's part 2 of your answer. So that's the degrees that the displacement vector is traveling. So now you can put it all together. You have both parts. So the displacement vector traveling from Ms. Clayton's room to Mr. Buford's room is 79.2 meters and is traveling at 43.93 degrees. So just to recap and make sure that you guys get the main points, you want to use summation if you need to make it a little bit easier on yourself. And you can draw a diagram to scale, because it definitely will help you figure out which measurements you need to find and what you want to do. And then you can use the Pythagorean theorem to find the distance or the hypotenuse or the displacement vector, whatever you want to call it. And then use the inverse sine using the answer that you got with the Pythagorean theorem to find the degree angle that same hypotenuse is traveling in. Well, I hope this helped. Thank you.